Our last operation with sets in this section is called the Cartesian product of sets A and B, and it consists of all ordered pairs A comma B, where A comes from your first element, your first set A, and B is an element of your first set B. We sometimes call this A cross B. Because of the cross right there. All right, so let's try an example. I'm going to let A be the set ABC and B the set EF, and we want to describe some cross products or Cartesian products here. So A cross B is going to be the set of all elements where my first element comes from A and my second element comes from B. So I'm going to have little a, comma, little e to start. And then little a, comma, f. And now I don't have any more elements of B to pair with little a, so I'm going to move on to element B here from set A. And so I get BE and BF. And now I'm going to move on to C. I get CE and CF. So if you notice, what I'm doing here is I'm going to start with an element of A and then list all ordered pairs that start with that element. And have a second element from B, and then repeat, okay? Let's try B cross A. So now my first element in my ordered pairs has to come from B, and my second element comes from A. So I'm going to start with an element of B, so say E, and I can pair that with A. I could also do EB and EC. And I can go FA, FB, FC. You can also cross a set with itself. So B cross B, the first element comes from B and the second element comes from B. So I'm going to have E comma E, then E comma F, and that's all I could pair with E. And then I'm going to have F comma E and F comma F. All right, so what is the number of elements in each of these sets? A cross B has 6 elements. B cross A also has 6 elements, and B cross B has 4 elements. I'd like you to think for a second how we might be able to figure out how many elements are in the Cartesian product without actually having to list out all the elements. What about A crossed with the empty set? Well, this one's a little trickier, but that's going to be the empty set. Okay, so if we want to take the cross product with an empty set, we just get the empty set. Okay, so the fundamental counting principle is what's going to help us count the number of elements in a Cartesian product. And what this principle says is that if there are M ways to perform our first task and B ways to perform our second task, actually, let me call this N ways to perform our second task, then the number of ways to do both tasks together is going to be the product M times N. So think back over here. There were 3 ways to assign the first element of my ordered pairs and 2 ways to assign the second element of my ordered pairs in A cross B. So there are 3 times 2, which is 6 elements in my Cartesian product. We could also visualize that with a table. So suppose I've got 3 different colored shirts and 2 different colored pants. How many different outfits could I make? I'm going to make a table where I put my shirts on the left-hand side in my rows and my pants on my columns. And each outfit is an ordered pair of a shirt and a pair of pants. Now you can see that I have 3 rows and 2 columns, and so inside my circle or inside my table I have 6 elements or 6 possible outfits. All right, so that's how we're going to find the number of elements in a Cartesian product. I just take the number of elements in A and multiply by the number of elements in B.